So the second way that I can simplify radicals is by finding perfect squares. So this is just another method that you can use instead of using a factor tree. So I'm going to take the same problem, the square root of 128. Remember, if we don't see the number in the index, we're going to always assume that it's 2. My goal in finding perfect squares is that I want to break down my radicand, or this 128, into factors with perfect squares. Okay, remember, perfect squares are those numbers that when they're squared and we take the square root of them, we'll get an easy number back. So it's 4, 9, 16, 25, and so on. Okay, so basically I want to break down this 128 into at least one factor that has a perfect square. Okay. So in my first step, I'm going to divide this by 2 again, right, if I want to break it down here, and I'm going to leave it inside the radical. Right, so I know that 128 can be separated or expanded into 2 times 64 here. Since I know my perfect squares and I've memorized them, I know that the number 64 is a perfect square here. All right, because I know that 8 squared equals 64. All right. So since I know that 8 squared equals 64, right, if I were to take the square root of 64, that would equal 8. And since 2 is a prime number, right, I'm going to leave it in the radical because I can't simplify that anymore. Since I'm taking the square root of 8, or the square root of 64, and I know that it's 8, right? I've simplified it, and I've undone the square root, so I can bring that to the outside here. Okay, so my final answer for the square root of 128 is 8 square root of 2.